Welcome to Signals and System subject classes. Now we're in the fifth chapter, that is continuous time Fourier transform. So this is a problem. Previously we have discussed that x of t equal to e power minus a mod t. For that we got the frequency domain signal. We do some more problems. So here now this continuous time signal I'm taking. So that is x of t equal to impulse signal. So x of t that equal to del of t. For that, what is the frequency domain signal? X of j omega. X of j omega is what? So this Fourier transform formula, sir. X of j omega formula. So first I'm writing x of j omega. That formula equal to integral minus infinity to plus infinity x of t into e power minus j omega t into dt. Inverse Fourier transform x of t is 1 by 2 pi integral minus infinity to plus infinity x of j omega e power j omega t into dt. So the Fourier transform x of j omega minus infinity to the plus infinity. What is the x of t? Del of t. E power minus j omega t into dt. We know that impulse signal is defined for t equal to 0 only. So multiplication, one multiplication is exist. So one multiplication existed. So that equal t equal 0. So del of t, so substitute t equal 0 here. So it goes to 1. The value equal to 1. X of j omega equal to 1. Means, so del of t its Fourier transform equal to 1. It means we want to draw the waveform. So del of t, this is the signal del of t. So del of t impulse signal defined for only so at t equal 0 only. So its Fourier transform is so x of j omega for example this is x of t. So x of t is impulse. So x of j omega equal to 1. So x of j omega versus omega. So for all values of the omega, it should have the magnitude equal to 1. This is GC line. Continuous time Fourier transform. So this is the case. Next problem. This x of t. So x of t equal to u of t. For this, so what is the Fourier transform? So this x of t, u of t is a unit step function. It is defined for only positive values. So x of j omega. So x of j omega equal to integral of. For the limit, we should take the limits from the 0 to infinity only. So within the limits, the u of t. So in the formula, we should take the x of t. X of t equal to u of t. In these limits, u of t that equal to 1. Is it 1 into formula e power minus j omega t into dt. So do the integration, exponential function integration, e power j omega t by will get minus j omega. It must be divided by the constant that equal to minus j omega. So limits values are so 0 to infinite. So e power minus infinity 0 and e power 0 that equal to 1 by minus j omega. So x of j omega that equal to 1 minus minus gets cancelled, then 1 by j omega. So this is the Fourier transform for the unit step. So this is the complex signal. Next problem. Now, so in this problem, we have to find the Fourier transform for the rectangular pulse. Rectangular pulse, we know that here one rectangular pulse. X of t, so it is having the magnitude from 1 in case of the mod less than t1, 0 for the out of interval. This is out of interval. So this is a case. So for this case, what is the Fourier transform? X of j omega is what? Question mark. So I would like to draw the time domain signal here for this. So these are the very, very important problem. So this is rectangular pulse. So it is not periodic, it is a periodic signal. So x of t minus t12 plus t1. For this, what is the Fourier transform? We will see that. So the formula x of j omega. So x of j omega equal to integral minus infinite to the plus infinite x of t into e power minus j omega into t into dt. So this given signal, it is having the magnitude from the minus t1 to t1 only. So in this, so I'm splitting to the minus infinite to the minus t1. For that, there is no signal. So it is having only minus t1 to t1. So remaining limits, it goes to 0. So just minus t1 to the t1. So its magnitude here, this except is this magnitude. For example, we are taking, I am taking this is 1 magnitude, is it? So except equal to 1. So e power minus j omega t into dt. So that equal to, so e power minus j omega t by minus j omega limits. So t1 minus t1. So the x of j omega, so x of j omega, so that equal to, so substitute limits values. So e power minus j omega t1 minus of e power, those limits, lower limit minus t1. So minus to minus plus. So j omega t1 by minus j omega. So minus, take the common in numerator. Minus, take the minus common in numerator. So this minus minus gets cancelled. E power j omega t1 minus of e power minus j omega t1 by j into omega. So this is the formula, like e power j theta minus e power minus j theta by 2j. So that equal to sine theta. So sine theta. So here 2 missing, is it? So multiply 2 by 2. So what happened? So sine theta. What is the theta? Omega t1. Omega theta 1. It's a t1 by omega. So this is the x of j omega. Same, it is similar to the Fourier series. I will show you. Actually, in formula, Fourier series formula, so x of t, rectangular pulse train, so rectangular pulse train, that is the one for the mod t less than t1 and 0 for the mod t1 to the t by 2. So this is a periodic signal. For that, we got ak equal to 2 sine, sorry, 2 sine 2 sine k into omega naught into t1 by k into omega naught into t. So the AK formula and Fourier transform formula. So this is the time x of t into e power minus j omega k into omega naught into t into dt. So this is modified. What is modified? X of j omega. So t, ak into t is the x of j omega. So minus infinite to plus infinite. So x of t into e power minus j k omega naught is considered as a omega into dt. So ak into t, see, ak into t, so ak into t, that is the x of j omega, okay, for the x of, so ak into omega naught, that is x of j k omega naught, so that equal to 2 into sine k omega naught into t1 by k into omega naught. Now replace the k omega naught by the omega. So x of j omega equal to 2 sine of k omega naught must be replaced by the omega. So t1 by the k omega naught. See, compare this one. X of j omega equal to 2 sine omega t1 into omega. So this is the periodic signal. That periodic signal we converted to the frequency domain, that equal to 2 sine k omega naught t1 by k omega naught t. So this is the formula. So in Fourier transform, we have taken the x of j omega, that is equal to the ak into t. ak into t considered as a x of j omega. So this x of j omega, now it is derived from the formula, and also it is similar to the same periodic pulse train, rectangular pulse train, is it? So this is the concept, this is the relation between the Fourier series and the Fourier transform. That you should remember. So compare, so from the Fourier series to the transform, Fourier transform, just k omega naught is considered as a omega, ak into t considered as a x of j omega. That is the difference. So this is the case. So here, so this is the 2 into sine omega t1 by omega. This is called sinc function. So sinc function, so you know the sinc function formula, sinc theta equal to sine pi theta by pi theta. So here I'm going to convert, so sinc function for that. So omega theta 1 and pi missing and theta 1, t1 missing. So 2 sine, I'm writing like this, pi omega t1 by pi by, so t1 also missing. First of all, I'm writing t1. So t1 missing here, t1 missing, and pi by pi. So this is the omega t1 by pi is a theta. Here I'm writing here. So so 2t1 sinc function, sinc theta equal to, so omega t1 by pi. So sinc function. So I'm going to draw that sinc function. So x of j omega versus omega. So the maximum value at omega equal 0, the maximum value 2 t1. This is the maximum value. Here I'm drawing the sinc function. So this is a sinc function. So this is first omega pi by t1. This is pi by t1. This is minus pi by t1. The second one is, so this is 2 pi by t1. This is second one, 2 pi by 2 pi by, sir, minus 2 pi by t1. This magnitude equal to 2 t1 at 0. So this is the sinc function. So you should remember the rectangular pulse Fourier transform, it gives the sinc function. So continuous time Fourier transform. So this is rectangular pulse. So this is called sinc function. Write the note. So very important. Fourier transform of rectangular pulse is sinc function. Sinc function in frequency domain. So this is the case. So next, another problem. Now we will take the signal in the frequency domain, then we will check it. We have to find it signal in the time domain. Still now we have taken the signals in the time domain. So here, so now I'm taking the x of j omega. So now what is x of j omega? So that equal to 1 for mod omega less than w. 0 for this mod omega greater than w. This is the case. So for this, what is the x of t? Signal in time domain. The case, again here drawing the signal in the frequency domain. That is a rectangular pulse in the frequency domain. Same concept. So omega x of j omega minus w plus w, the magnitude equal to 1. So inverse, this is called inverse. We are doing the inverse Fourier transform. So inverse Fourier transform, that is x of t. So x of t, so formula 1 by 2 pi integral minus infinite to the plus infinite x of j omega into e power j omega t into d omega. So it is having magnitude from the minus omega to plus omega only. The limits, these are limits for the omega. So remaining limits, the function magnitude equal to 0. So minus w to the plus w. So the x of j omega magnitude equal to 1 into e power j omega t into d omega. We're doing the integration with respect to omega. So the integration j omega t. So your constant is the jt. So 1 by 2 pi. The constant is jt, not omega. We are doing the integration with respect to omega. So limits are minus w to the plus w. So 1 by 2 pi. So e power j wt substitute in place of the omega w. So t minus e power minus j omega minus j w into t by j into t. So the x of t equal to, so this is e power j theta minus e power j theta by 2j. So what left? 1 by pi t. So 2j, here I'm taking the 2 into j. So that equal to sine wt. So x of t equal to sine wt by pi t. Sine wt by pi t. Now convert the sinc function. So the sinc function, sinc theta equal to sine pi theta by pi theta. So here I'm writing the x of t equal to sine pi by wt by pi by, so here w is missing, so divide by the pi. So here I am writing like this. So theta we should have, is it? So wt pi into w by pi, the original pi, is it? So this is the theta. So this is pi, this pi is this one, this w. So then x of t w by pi sinc theta that equal to wt by pi. So you can write, can draw that Sinc function. Now this x of t is a sinc function. X of t is a sinc function that equal to w pi by sinc wt by pi. So t. So this is so this is so the magnitude equal to this is magnitude equal to double by pi. At t equal 0, at t equal 0, you apply the t equal El Hospital rule, you will get the double by pi at t equal 0. So this is reverse pi by w. Pi by w. So this is 2 pi by w. For this case, 2 pi by w, the magnitude equal 0. So here minus pi by w. So this is 2 pi minus 2 pi by w. So this is a sinc function. Here also we are getting sinc function. So sinc function Fourier transform, continuous time Fourier transform is rectangular pulse. So in previous case, rectangle plus Fourier transform is a sinc function, vice versa. So this property is called duality property. So here I would like to draw the sinc function actually in terms of the theta. So sinc function, sinc theta. So sinc theta versus theta. It goes to 0. The peak values are with respect to theta, it decreases, sorry. So this is a theta 1, theta 2. These are the theta values, -1 and -2. Here this t values, t value for the t equal, whenever t equal to pi by omega w, it will be 0. So this is the case. This is the sinc function. Sinc function. Sinc theta function. So in duality, so duality property, so duality property, same thing. So now in duality, the rectangular pulse Fourier transform is a sinc function. That is we should draw. T versus x of t versus minus capital T1 plus T1. This is x of j omega. It's so x of j omega, that value equal to 2t1 2t1 sync theta. The theta equal to omega t1 by pi. This is pi by t1. This is 2 pi by t1. Similarly, this is negative side minus pi by t1, and this is minus 2 pi by t1. Continuous time Fourier transform. Similarly, so minus w to the plus w, magnitude equal to 1. For this case, so inverse Fourier transform of this rectangular pulse, it is the sync. So x of t. So this is w pi into sync of sync wt by pi. Cyclic once. Sync w pi by t is correct. Actually, I remember the formula actually, but so this is the magnitude of the maximum 2t1. So similarly, So the peak value that equal to W by pi. This is pi by W. This is 2 pi by W. This is minus pi by W. So this value minus 2 pi by W. So, so continuous time Fourier transform. So this is called duality. What is a duality? See, for the sink and rectangular. Same rectangular Fourier transform in the sink Fourier transform in the rectangular. So this is called duality property. Here to here and it is called duality property. You may get question from here. This concept duality. So rectangular pulse Fourier transform is the sink function and rectangular pulse Fourier transform. Sorry, inverse Fourier transform is the sink function. J omega formula equal to 2 sine omega t1 by omega. Here this x of t formula x of t equal to sine w t by pi t. So this is I remember these formulas. So this is a case. So this is about Fourier transform and inverse Fourier transform and duality and everything. I have given the information. So next class we will discuss properties of the Fourier transform. Same similar to the what we have learned in the previous case in case of the continuous time Fourier series and discrete time Fourier series. Thank you.